Now from the Boston Museum of Science, Sci-Tech Today on NECN.
It has happened again, another accidental discovery leading to a scientific breakthrough, a material that cleans polluted water. Joining us live from the Museum of Science Boston is nanotechnology correspondent Corrine Tate. Thanks for joining us, Corrine.
Happy to be here.
So how did this come about?
Well, in 2005, a student in Paul Edmiston's chemistry lab, a girl by the name of Colleen Burkett, was working with a very fine nanostructured glass powder, trying to find a chemical detector for explosives. And she was experimenting with this powder, adding acetone to it. And she noticed that when she added acetone to the mixture, it swelled up, expanding to many times its original volume. And poor Colleen thought she'd made a mistake. So she showed the response to Dr. Edmiston, who had a hunch that this unusual reaction just might be useful in some way. And it turns out that the tiny pieces of glass in this powder are actually complex nanoscale networks of molecules. And this model demonstrates what's happening with the network at the molecular level. You see, normally it's in this compact, collapsed, tension-filled state. And it's hydrophobic, so molecules of water cannot get inside. But molecules of carbon-based pollutants like pesticides can get in. They expand the network, letting it swell and expand. They release the tension, and molecules of the pollutants can get in. And another way to show this idea is watching how a dried up sponge expands and swells as it absorbs and sucks in the water. But unlike a regular sponge, the glass powder can't absorb any water. It can only absorb the chemical pollutant. And we actually have a video of Dr. Edmiston in his lab demonstrating how the glass powder could be used to clean up an oil spill.
What I have here is a beaker full of clean water, which I'll make dirty by actually pouring unleaded gasoline onto the surface of the water.
Here Dr. Edmiston is pouring some gasoline on top of clean water to simulate an oil spill. He adds in the glass powder and you can see it absorb the gasoline, swell, and clump up on the surface in a gel. He then skims the gas-glass mixture off the top and filters the water to get the rest of the glass out. Now he's ready to test the results.
Just like the tap.
It's clean enough to drink.
Very interesting, Corrine. How do they dispose of the gel once it's absorbed the pollutant?
That's a great question, and that's one of the remarkable things about this glass powder is that it's reusable. Just like you use your hands to wring the water out of a sponge, you can use heat to wring the pollutant out of the glass powder. That way you can safely dispose of the chemical pollutant, but use that same glass powder again and again.
And are they actually using this technology?
They are. They've tested it in several sites in Ohio where some dangerous chlorinated solvents have leached into the ground, polluting the groundwater. We did a little animation showing the groundwater cleanup. Let's take a look at that.
Time ago, chemicals seeped from this factory into a groundwater reservoir and remain there, a constant threat to the town's water supply. The researchers inject the glass powder combined with iron nanoparticles into the polluted layer. The nanoglass expands as it absorbs the pollutants, and the nanoparticles render them harmless.
All righty, Corrine, we are out of time. Thank you so much for joining us from the Museum of Science in Boston.
Thank you very much. Happy to be here.
And join us every Thursday morning at this time for Sci-Tech Today. You can also log on to the Museum of Science website, mos.org.